Now we're going to be drawing circular patterns with trigonometry and eventually draw a clock, which is an interesting example. So a brief review of trigonometry 101. When we have Cartesian coordinates, which is what we've so far worked with in TK Inter, it's x comma y. However, to draw a circle, we want to convert from Cartesian to cylindrical. And r is going to be the magnitude, the distance from your point to a specified origin 0, 0 for now. And then theta starts from the x-axis and extends around the unit circle to 2 pi, which is in radians, or 360 in degrees. So then x is defined at this point. This x is going to be r cosine theta, and then y is going to be r sine theta, given that we are at the origin 0, 0 as an offset. So that's how you convert from Cartesian to cylindrical, but then if you have a circle that's an offset by cx and cy, you can see that the origin is actually here, and then we now have a new point at cx, cy. Then x prime, y prime is going to be cx plus r cosine theta and cy plus r sine theta. Now we're still in the mathematical framework, so this should be relatively nice review. But then once we convert or move toward Python graphics, we know that one thing has changed, right? Because up is down. So then as we go further up in their mathematical Cartesian plane, we know that we're actually going further down in our y value. So x is still the same, where you have cx plus r cosine theta. But then your y is just going to be subtracting from your original origin at cy. So this y right here is actually a lower value, so it'll be cy minus r sine theta. And we can do a really good example of this by drawing this following clock, which is a circle that's filled in with yellow. And notice that these numbers are drawn in a way that it's inside the clock, so they're also drawn in a circular pattern. And I've copied the code over to TK Inter. So one interesting thing to note that's different from our original definition of theta is that we're going to be starting from 0 and going to 11. And then when we're at 0, that's actually going to be our 12th hour. So then, because we're starting at this point and then going in this clockwise fashion, right, because the clockwise makes sense, we're actually going to be, that's going to be offset from our original point that starts at 3 and then goes counterclockwise, because that's how we define as our unit circle up here, right? This is our fashion where theta is increasing positively, and it starts at this point, whereas here we're starting up here. So then we're going to have to, when you think about it, there are different ways of thinking about it, but the easiest I would say is to start at an offset of pi over 2, which is this 90-degree angle offset from 3. And then instead of going in our fashion of counterclockwise, we're going to go the opposite direction. So we're going to be decreasing our theta value. So negative theta increases along the way, drawing from 1 all the way to 11. So you could draw, you could force it so that you could draw from 3 and then go to 4, but I think it's clearer if you start from the hour. So in that sense, that's what this line does right here. It starts at an offset of pi over 2, and it goes in the counterclockwise direction, which is negative, and this is the increment. So because we have 12 hours, it goes by a different increment starting from the original offset. So when you go to the 11th hour, you're pretty much all the way around the circle, and you're going to be subtracting a much larger fraction of 2 pi, which is the full way of theta around the circle. So let's look at the code up here. This is drawing our yellow circle, fill yellow, so this is specifying our starting origin that's offset because it's in the middle of the screen, which we see right here as width over 2, height over 2, and then the R is just saying that we don't want our clock to be off the screen, so it's going to be the minimum of whichever is a smaller length, and then that'll be just a third of the screen. We're going to create it at that specified left top and right bottom, so up here is going to be offset by R, and then up here is offset by R. That's also going to be cx minus R, because in here we have a smaller x, smaller y, and then we have a larger x, larger y, so that's in comparison to each other, which is, and the origin cx, cy, which is defined here, cx minus, okay. And then our R, our next value of R is just like when we create the actual labels, that's going to be 0.85 of the actual radius of the original yellow clock. And that's just for visualization. And it's important to note that once we account for the hour angle that we've seen, starting from that interesting position 12 and going to 11, because 12 is when hour is equal to 0, then we don't really have to worry about that when we actually create our x position and our y position. we use the original understanding that it's our cx plus r and cy minus r because we've already accounted for that interesting angle change. So this is important that you make this differentiation when you draw your clock. And then we're going to be labeling it based on our current label, so string of this hour number, and let's see what it looks like. So yeah, it's a nice clock. We have it inside the circle. It's a little bit interesting, it's a little offset, but this is done in a very clear fashion. So this is how you would draw a clock using this framework for trigonometry 101.